Good morning. Here's your daily tech briefing for 2020-60815. Today we're covering Java, Liferay DXP, Apache Kafka, Docker, Kubernetes, Git, Angular, and Cloud, AWS/Azure/GCP, plus the Architect's Corner. Let's get into it. Let's dive into the world of Java, where some interesting developments have caught our attention. First off, there's a new project that's making waves, called Rust Codegen JVM. This project allows you to compile Rust code into Java bytecode, which can then be packaged into runnable jar files. For those who may not be familiar, Rust is a programming language that's known for its focus on safety and performance, and it's often used for systems programming. Java bytecode, on the other hand, is the intermediate form that Java code is compiled into, which can then be run on the Java Virtual Machine, or JVM. The ability to compile Rust code into Java bytecode opens up some interesting possibilities. For example, it could allow developers to write performance-critical code in Rust, while still being able to integrate it with existing Java applications. This could be particularly useful in areas like Android app development, where Java is still widely used, but performance is critical. The project is hosted on GitHub, and it's still in the early stages, but it's definitely worth keeping an eye on. Moving on, if you're interested in learning more about the history of Java, there's a new documentary out that's worth checking out. The Java Story is an official documentary that takes a look at the origins and evolution of the Java programming language. The documentary is available on YouTube, and it's a great resource for anyone who wants to learn more about the context and motivations behind Java's creation. With only one comment on the Hacker News post, it's clear that this documentary is still flying under the radar, but it's definitely worth watching for anyone who's interested in the history of programming languages. It's worth noting that Java has had a profound impact on the world of software development, and its influence can still be seen today. From Android apps to enterprise software, Java is still widely used, and its ecosystem is still thriving. The documentary provides a unique glimpse into the early days of Java, and it's a great way to learn more about the people and events that shaped the language into what it is today. The combination of these two developments, the ability to compile Rust code into Java bytecode, and the release of a documentary about Java's history, highlights the ongoing evolution of the Java ecosystem. As the programming landscape continues to shift and change, it's interesting to see how Java is adapting and evolving to meet the needs of modern developers. Whether you're a seasoned Java developer or just starting out, these developments are definitely worth keeping an eye on, and they're a great reminder of the ongoing importance of Java in the world of software development. Liferay DXP, a popular enterprise Java-based portal framework, has seen a new development that could simplify the workflow for its users. A command line interface, or CLI, tool has been introduced on NPM, the package manager for JavaScript, under the name Stylebook Token Generator. This tool is designed to generate tokens for Liferay Stylebook, which is essentially a design system for creating consistent user interfaces within Liferay DXP. For those who may not be familiar, Liferay Stylebook is a crucial component for maintaining a cohesive look and feel across various portals and websites built on the Liferay DXP platform. It provides a set of predefined UI components and guidelines that developers can follow to ensure consistency in design. However, working with Stylebook often requires manually generating tokens, which can be tedious and prone to errors. The introduction of the Stylebook Token Generator (CLI) aims to automate this process, making it easier for developers to integrate Stylebook into their projects. By using this tool, developers can quickly generate the necessary tokens, saving time and reducing the likelihood of manual errors. This can significantly streamline the development process, especially in large-scale enterprise environments where consistency and efficiency are key. Although the tool has just been announced and hasn't garnered much discussion yet, its potential impact on the Liferay DXP community could be substantial. For companies and projects that heavily rely on Liferay DXP for their intranets, customer portals, and content-managed websites, this tool could become an indispensable asset in their development toolkit. As more developers begin to use and provide feedback on the Stylebook Token Generator, we can expect to see its capabilities expand, further enhancing the overall Liferay DXP experience. Apache Kafka has been a cornerstone of many distributed systems, enabling high-throughput and fault-tolerant data processing. For engineers working with Kafka, interacting with the platform can sometimes be cumbersome, especially for those on macOS. Recently, a new tool has emerged to simplify this process: Streambench, a native Mac client for Kafka and NATS. Streambench aims to provide a user-friendly interface for developers to work with Kafka and NATS, two popular messaging systems. By offering a native Mac application, Streambench fills a gap for macOS users who previously had to rely on command-line tools or third-party applications that might not be as intuitive. The tool allows users to produce and consume messages, browse topics, and even test the performance of their Kafka and NATS setups. The creation of Streambench highlights the ongoing demand for more accessible and user-friendly tools in the ecosystem surrounding Kafka. As Kafka continues to be widely adopted in industry and enterprise environments, the need for straightforward and efficient management and debugging tools grows. Streambench, with its focus on simplicity and native integration with macOS, addresses this need for Mac users, potentially streamlining development and testing processes for Kafka-based applications. Although Streambench has just been introduced and has garnered limited feedback so far, with only 2 points and 1 comment on Hacker News, it represents an interesting development in the Kafka ecosystem. Its utility and ease of use could make it a valuable asset for developers and engineers working with Kafka on macOS, enhancing their productivity and reducing the complexity associated with Kafka operations. As the tool evolves and gains more traction, it will be interesting to see how it impacts the workflow of Kafka users and whether similar solutions emerge for other platforms. Docker has been making waves in the development community with its latest blog post on reproducible ESP32 firmware development. For those who may not be familiar, ESP32 is a series of low-power, low-cost microcontrollers with integrated Wi-Fi and Bluetooth capabilities, commonly used in Internet of Things, or IoT, projects. The challenge with developing firmware for these devices is ensuring consistency and reliability across different environments. This is where Docker comes in. By utilizing Docker environments, developers can create reproducible builds of ESP32 firmware, which means that the build process is consistent and predictable, regardless of the underlying system or dependencies. This is particularly important in IoT development, where small changes in the firmware can have significant effects on the device's behavior. Docker achieves this by providing a containerized environment that isolates the build process from the host system, ensuring that all dependencies are carefully managed and versioned. The blog post also highlights the use of Docker sandboxes, which allows for isolated AI-assisted development and hardware testing. This means that developers can test and validate their firmware in a sandboxed environment without affecting the host system or other projects. This approach enables faster iteration and debugging, as well as improved collaboration among team members. The use of Docker sandboxes also enables developers to test their firmware on simulated hardware, which can reduce the need for physical prototypes and speed up the development process. By leveraging Docker and Docker sandboxes, developers can streamline their ESP32 firmware development workflow, ensuring more reliable and efficient development of IoT projects. Kubernetes has been a cornerstone of container orchestration, allowing engineers to automate deployment, scaling, and management of containerized applications. However, a recent discussion on Hacker News highlights a crucial aspect of Kubernetes configuration that has sparked debate: the use of CPU limits. The post, titled "For the Love of God Stop Using CPU Limits in Kubernetes," has garnered significant attention with 40 points and 42 comments, prompting a closer look at the reasoning behind this stance. The argument against using CPU limits in Kubernetes stems from the potential for throttling, which can significantly impact application performance. When a container exceeds its allocated CPU limit, Kubernetes throttles it, essentially limiting its ability to utilize more CPU resources even if they are available. This can lead to increased latency and decreased throughput, directly affecting the user experience and overall application efficiency. The discussion references an analysis available on GitHub, which delves into the specifics of how CPU limits can be detrimental. The analysis suggests that instead of using CPU limits, engineers should focus on setting appropriate CPU requests. CPU requests in Kubernetes are used for scheduling purposes, helping the system understand how much CPU a container is expected to use. By accurately setting CPU requests, engineers can ensure their applications are scheduled on suitable nodes without the risk of throttling associated with CPU limits. This insight is particularly relevant for engineers working with applications that have variable or burstable workloads. By understanding the implications of CPU limits and focusing on accurate CPU requests, teams can optimize their Kubernetes configurations to improve application performance and reliability. As the discussion continues, it's clear that the Kubernetes community is actively exploring best practices to maximize the potential of container orchestration, and this conversation is a valuable contribution to that effort. Git, the version control system used by many developers, has seen a significant enhancement with the introduction of agent apps on GitHub. For those who may not be familiar, GitHub is a web-based platform that uses Git for version control and collaboration. Agent apps are automated tools that can perform specific tasks within GitHub, making it easier to manage the software development lifecycle, or SDLC. Recently, GitHub highlighted how 4 of their agent apps can help streamline the SDLC process. These apps can assist with scoping, securing, rolling out, and shipping a feature, all without leaving the GitHub platform. This means developers can now manage their entire workflow from start to finish in one place. The scoping app helps define the project's requirements, the securing app ensures the code is safe and secure, the rollout app assists with deploying the feature, and the shipping app helps with the final release. This integration is significant because it reduces the need to switch between different tools and platforms, making the development process more efficient. By bringing the entire software delivery workflow into GitHub, developers can focus on writing code and collaborating with their team, rather than managing multiple tools. Many companies and projects already use GitHub for version control, so this enhancement will likely have a significant impact on their daily workflow. With these agent apps, developers can automate repetitive tasks and focus on more complex issues, ultimately leading to faster and more reliable software delivery. In the Angular community, there's been a significant focus on evolving form handling and integrating artificial intelligence, or AI, into front-end development. Recently, experts have been exploring the history and development of Angular forms, from traditional template-driven approaches to more modern signal-driven methods. This shift is important because it reflects a broader trend in software development towards more reactive and dynamic user interfaces. Sanu Kapoor, a community expert, has written about the evolution of Angular forms, highlighting the benefits of signal-driven approaches, which allow for more flexibility and scalability in form handling. This is particularly relevant for enterprise applications, where complex forms and user interactions are common. By adopting signal-driven forms, developers can create more responsive and user-friendly interfaces, which can improve the overall user experience. The integration of AI in Angular development is also gaining traction, with discussions around client-side AI and its potential applications in areas like form validation and user feedback. This trend is likely to continue as AI and machine learning technologies become more prevalent in software development. For developers working with Angular, particularly those paired with Java or Spring Boot backends, understanding these advancements can help them create more modern and efficient front-end applications. Companies like Google, which maintains Angular, and other enterprises that rely on the framework, are likely to be impacted by these developments, as they continue to push the boundaries of what's possible in front-end development. Google Cloud Platform has made some important updates to its App Engine flexible environment, specifically for Go and Java applications. As of August 2026, App Engine will be opting applications into TLS version 1.2 and later by default, in an effort to improve security. This means that any incoming traffic using earlier versions of TLS, such as 1.1, will no longer be supported. For those who may not be familiar, TLS, or Transport Layer Security, is a protocol used to secure communication between a website and its users. It's essentially a way to ensure that data exchanged between the two remains confidential and tamper-proof. The earlier versions of TLS, such as 1.1, have been found to have some vulnerabilities, which is why Google is pushing for the use of more secure versions like 1.2 and later. Developers have until the end of August 2026 to opt out of this change if needed, but starting in September 2026, App Engine may permanently block any traffic using TLS 1.1 or earlier. This is a significant change, as it could potentially break applications that rely on older TLS versions. Companies using App Engine for their Go or Java applications should review their configurations and make any necessary updates to ensure compatibility. Google has provided more information on this change in their documentation, which can be found on their website. It's worth noting that this change only affects the flexible environment, so developers using the standard environment will not be impacted. Now, let's shift gears for the Architect's Corner. 5 minutes on real enterprise software architecture and system design. The problem of tracking vehicles at scale is a complex one, especially in a country like India, where the logistics market is highly fragmented. Bosch Mobility Platform Solutions faced this challenge head-on when they set out to build LOS, a platform that would unify the spot logistics market into a single real-time visibility layer. The team had to design a system that could handle a large volume of vehicle location data, process it in real time, and provide accurate tracking information to users. This was no easy task, given the sheer scale of the problem, thousands of vehicles generating location data every few seconds. To tackle this problem, the team at Bosch decided to build a serverless vehicle tracking platform on Oz. They chose to use a combination of Amazon ECS, AWS Lambda, and Amazon MSK to design a scalable and fault-tolerant architecture. The use of serverless technologies allowed them to focus on writing application code rather than managing infrastructure, which was a key requirement given the scale of the problem. Amazon ECS was used to manage the containerized application, while AWS Lambda provided a scalable and event-driven compute service for processing vehicle location data. Amazon MSK, a managed streaming service, was used to handle the high-volume and high-velocity data streams generated by the vehicles. The solution that the team built was highly scalable and able to handle the large volumes of data generated by the vehicles. The use of serverless technologies allowed them to quickly deploy and test new features, without having to worry about the underlying infrastructure. The architecture was also designed to be highly available, with built-in redundancy and failover capabilities to ensure that the system remained operational even in the event of component failures. By using Amazon MSK to handle the data streams, the team was able to process the vehicle location data in real time, providing accurate and up-to-date tracking information to users. So why does this matter to a working software architect? The key takeaway from this case study is the importance of choosing the right architecture and technologies for the problem at hand. In this case, the use of serverless technologies and managed services allowed the team to focus on writing application code and deploying a scalable and fault-tolerant system. The solution also highlights the importance of designing for scalability and availability from the outset, rather than trying to bolt these features on later. By using a combination of Amazon ECS, AWS Lambda, and Amazon MSK, the team was able to build a highly scalable and available system that could handle the large volumes of data generated by the vehicles. The use of serverless technologies also highlights the trade-offs that need to be considered when designing a system. While serverless technologies provide a high degree of scalability and flexibility, they can also introduce additional complexity and cost. The team at Bosch had to carefully consider these trade-offs when designing their system, and ultimately decided that the benefits of serverless technologies outweighed the costs. This is an important lesson for any software architect, as it highlights the need to carefully evaluate the requirements of the problem and choose the right technologies and architecture to meet those requirements. In terms of when this pattern applies elsewhere, the use of serverless technologies and managed services is likely to be relevant in any scenario where there is a need to handle large volumes of data or provide real-time processing capabilities. This could include applications such as IoT sensor data processing, real-time analytics, or streaming media services. By understanding the trade-offs and benefits of serverless technologies, software architects can make informed decisions about when to use these technologies and how to design systems that take advantage of their capabilities. Finally, it's worth noting that the solution built by the team at Bosch is not without its potential pitfalls. One potential issue is the cost of using serverless technologies, which can be higher than traditional infrastructure-based approaches. Additionally, the use of managed services can introduce vendor lock-in, which can make it difficult to migrate to a different platform or technology stack. By carefully evaluating these risks and considering the trade-offs, software architects can make informed decisions about when to use serverless technologies and how to design systems that are scalable, available, and cost-effective. And that's your briefing for today. See you tomorrow morning.